Hi, Mwanu, how are you doing? And then Mroma just joined. Hi,
I'm
Mroma,
good and
how
you,
are you?
sir. I'm good and you, sir.
And Tabile
Hello,
just joined. How
sir.
are you, Tabile? Oh, you
I'm
guys,
good.
it seems like you guys are very, very, very energetic tonight, eh? I like it. How is the whole day going?
Fine, sir.
Sir, you don't
Oh,
have a
yeah.
holiday.
You don't have a holiday?
Mm-mm.
Oh, man. That's too good, eh? You deserve it. You guys deserve that, man. You're Madrid. Let me just dive into today's business. Uh, boom. Can you guys see something that side?
Yes, sir.
Yes, sir.
Oh, all right. Thank you, guys. Thanks for those energetic feedbacks. I love hearing that. Let me then go to my grade 12 course that I will be doing. I want my action series. The grade 12 one, this one. All right. Then this is what we will be doing tonight. All right. Can you all guys hear me? I'm now starting tonight's lesson.
Yes, sir.
Yes, sir.
Okay. Okay. I love hearing those energetic feedbacks. Oh, it seems like I'm going to enjoy tonight's lesson. So tonight, guys, we are going to do similarity, which is very, 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 very important there in grade 12. I think it contributes a lot there in Euclidean geometry. So they are saying there, oh, firstly, guys, is my zooming okay? Should I zoom in a little bit or out, or is it okay?
It's fine.
Are you sure?
It's fine, sir.
Oh, all
Yes.
right, all right, all right. Thank you, guys. So here they are saying polygons are said to be similar if they have the same shape, but not necessarily the same size. Okay, we noted that they might differ in size if two polygons are similar. The one is an enlargement of the other. So maybe if the other polygon, maybe polygon A is of a size K, then the polygon B is of the size of 2K, is multiple, I mean, is 2 times larger the other one. Then we can say those polygons are similar. Okay, then they are saying there, formally, we say that two polygons are similar if and only if these conditions are met. These conditions here. If they are met, then you can say those polygons are similar. Then let's see what these conditions are saying to us. If all pairs of corresponding angles are equal. Okay, and we can see that here is a dot, dot, star, star, O, O, square, square, X, X. Okay, then you can say those are similar. Then let's go for the other condition. They are saying all pair of corresponding sides are in the same proportion. If this is A, this will be Ka, is the scalar multiple of that corresponding side in the smaller polygon. Okay. I believe that makes sense to you guys. Does it make sense to you guys? Those two conditions that needs to be met in order for us to conclude that two polygons are similar.
Yes, sir.
Yes, sir.
Okay, thank you guys. Now they are saying both of these conditions have to be met for two polygons to be similar. Those two conditions. First condition is saying all pairs of corresponding angles needs to be equal, and all pairs of corresponding sides are in the same proportion. Then with the sides, those sides are not equal, but they are in the same proportion. Then one side is the scalar multiple of the other side. Okay. Then now we go to this part, the triangles. They are saying for triangles, any one of two conditions, either equal angles or proportional sides, is sufficient to guarantee similarity. If maybe you won with this side, there's no need for you to also go to prove this. You can just conclude that those two triangles are similar. Or let's say you saw that this condition is met. There's also no need for you to go for that one. You can just conclude from this condition that those two triangles are similar. And that only applies with triangles, but for the other polygons, they all need to be met, this condition. Does this make sense to you all, guys?
Yes, sir.
Okay, then let's continue with that paragraph. There are theorems which states that if any one of the conditions apply, then other conditions automatically apply as well. This is only true for triangles. Okay, I've said that. For all other polygons outside of triangle, because for the triangle, if one holds, the other one automatically holds. But for other polygons, two of them need to hold for similarity. Okay, now let's go for the notation. They are saying, I'm now here, guys. I'm now here. Now they are saying the triangle cut, CAT. This one triangle here. Okay. Or is that similar? So guys, please just note the difference between the similarity. This is the similarity and the congruency. This is the congruency. This is the similarity. The vertical ones, they mean that similarity. And then this horizontal one, they means a congruency. Okay. Then this notation here means that triangle cut is similar to triangle dog. Okay. In this notation, the order in which the letters are written is so important. I will emphasize that when we get to the problem first. But the order is important as it indicates which angles are equal. Okay. Now we are here in these diagrams, these triangles. We just want to see how are they similar. So going to triangle CAT, we take the letter C, which is the first letter in the triangle cut. That will be equal to the first letter on the other triangle, D on the other triangle. Then we are given that. Okay, then the second letter A, angle A, will be equal to the second letter on the other triangle, O, angle O. And we are also given that A and O, okay? The last one, T, is equal to the last one, G there. Okay, those angles are equal. We are given that. Does this part make sense to you all, guys?
Yes, sir.
Yes, sir.
Okay, thank you guys for the feedback. Then now we can just cook some ratios. I love cooking. Now we can cook some ratios from those similar triangles. Those ratios, how are we going to cook them? So we have triangle cut, or this is a triangle cut, is similar to triangle dog. My dog. Let me just write that here. Triangle cat. Now, similar to triangle dog, my spotty here. This is my spotty here. Dog. So how are we going to cook our ratios? Okay, you take the first two letters on the first triangle, CA, this one. Okay, CA over the first two letters on the other triangle DO. You're going to say CA over DO. Okay, that will be equal to. We can now take the last two letters, AT, okay, over the other last two letters, OG. You take the outer letters, CT, all over the outer is DG there, DG. Okay, then your reasoning is similar triangles. Does this part make sense to you guys?
Yes, sir.
Okay, thank you guys. Then this part here is just showing you that you can play around that, just like we did play around even there in proportionality theorem. That was theorem 1, then this is theorem 2, the similarity. Now they are saying, stop. Okay. Now here they are saying the triangle similarity theorem, theorem 2. Theorem 1 was the proportionality theorem. Don't forget that theorem, guys. It will help you a lot. If two triangles are equiangular. Anyone, guys, who can tell us what does that term equiangular mean? Is there anyone, guys?
All the angles are equal.
Oh, yes, 100% correct. I agree. Therefore, if triangle ABC is equiangular with that triangle DEF, means that then this angle will be equal to that, this will be equal to that, this will be equal to that. Okay. Now they are saying if two triangles are equiangular, then their corresponding sides are equal or are in the same proportion, are in the same proportion, and hence the triangles are similar. Huh? Does it make sense? If two triangles are equiangular. Now, if we know that these triangles, all angles are equal, the corresponding angles are equal, okay, then the corresponding sides are in the same proportion, and hence the angles are similar. Okay, then meaning if we take corresponding sides, now if I take AB over DE, that will be equal to AC over DF, and all be equal to BC over EF. Does this make sense to you guys?
Yes, sir.
Okay. Now they are saying if we are given that triangle ABC and triangle DEF, with angle A is equal to angle D. Okay, conclusion, you can say that AB over DE is equal to AC over DF, BC, BF. Okay, it's all right. Hence, those triangles are similar. Reason being angle, angle, angle. Those angles, we knew that they were all equal. Now, using angles to prove that triangles are similar. Okay, example 14. In the sketch alongside AB is parallel to DE. This is AB is parallel to DE, and again AC is parallel to FE here. Okay. Okay, therefore, if those lines are parallel, this angle will be equal to that, this will be equal to that, corresponding angles. But okay, let's go to the question and see what it requires us to do. Prove that triangle BCA, BCA is this one, is similar to DFE, this one. Now, let's see what we can do, because now we are going to use angles to prove that these two triangles are similar. Now, we go for angle A there. angle A is this one. Or we can say that is equal to what? But okay, we go to the first letter of the triangle, that one on the left, BCA. We go for angle B. Okay, that must be equal to the first letter there in triangle DFE. Okay, angle B is equal to angle D, reason being alternate angles. Then because of these parallel lines, AB is parallel to DE, we form that Z shape. You state your reasoning alternate angles, then you also state your given parallel lines. Okay, you go for the second letter in the triangle BCA. BCA for angle C there. C is this one. You also go for the second letter on the other triangle TFE. You go for F there, which is this one. Okay, they are all equal those angles because of this Z. Alternate angles are equal. Then you state your parallel lines. AC is parallel to FE. Okay. Because with the triangles, we've got 3 triangles. Then I can just, let me say, okay, if you've shown that this is equal to that, give some reason, and this is equal to that, give some reason. This angle will automatically be equal to this angle, reason being the third angle of a triangle. That's why now, okay, we already found the 2 angles in the 2 triangles. Now we are going to say this angle here in the left triangle is equal to angle E in this right angle triangle. This angle is equal to that angle, reason being the third angle of a triangle. Then after that, we used all the angles. We are going to say those triangles are similar, reason being angle, angle, angle. Does this part make sense to you guys?
Yes, sir.
Okay, thank
Yes,
you.
sir.
Okay, guys. Please don't forget, guys, you're more than welcome to shout out if you don't understand something, or maybe you are left behind or moving too fast. You can shout out. Stop me. I don't mind stopping. Now, okay. With number B, let me just do this. Okay. With number B, we are required to prove that AB times EF is equal to AC times ED. So how can we do that? Okay, we said using those triangles. If we are now sure that triangle BCA is similar to triangle DFE, okay, we can just simply go to those triangles. You take the first 2 letters on the left triangle BC, going to take that BC, okay? BC over the first 2 letters on the right triangle DF, DFE, taking over DF, there, DF. Okay, that will be equal to, now taking the last letters, okay, on the left triangle CA, okay, over, on the right triangle, the last 2 letters is FE, FE. That will be equal to, okay? Now we take the outer letters, BA, BA over ED. Not ED, rather, DE. Okay, DE. So now we are having AB times EF. Okay. Okay, this is our AB or BA. Doesn't matter. Okay, we have ED or DE here. Okay, we also have AC or CA here and EF or FE here. So we are just going to go for that part, this part here. Okay, CA over FE is equal to BA over DE. Then you cross multiply that. Okay, CA times DE DE is equal to BA or AB, whatever it is, doesn't matter. And then BA with FE or EF. Then you are done, just like that. Does number B make sense to you guys?
Sir,
Yes, ma'am.
is it okay if I put the same sides, if I put sides from the same triangle over each other equal to the same, to the sides that are corresponding with those sides on the other triangle?
I'm not sure if I understand your question. Can you please repeat your question?
Okay, so let me give an example. Like, for example, you said you said CA over FE, right? And
BA over FE, yes.
yes, but I opted to say BA over CA equal to DE over FE. So it's the same, it's sides from the same triangle equal to the ones that are proportional to it from the other triangle.
Oh, let me just write what you are saying, maybe I will understand. You are saying BA or CA. Can you please just say what you are saying?
BA over CA,
You are saying BA over CA,
yes,
okay?
equal to DE
Equal
over FE.
DE
Yes,
over
FE.
FE. DE over FE. And then,
Cross multiply.
yes, that also will give you the same answer. Yes,
Okay,
that's still
thank you.
that's still the good approach. I agree.
Thank you.
Yes. Oh, now I left the reason. I'm sorry, guys. But here, from this statement, we're supposed to accompany that statement with some reason here. The reason is going to be similar triangles. Then you are done. Okay. Does it make sense to everyone, guys? Before
Yes,
I
sir.
can move to the next part. Okay, thank you, guys. Then the next part. Okay. Now, example 15. So we are saying here in the sketch alongside SR is a tangent. SR. Here is SR. This is SR here. Is a tangent to the circle PTS to this circle. Okay. We noted that. At S. Okay. Now prove that triangle PRS is similar to triangle SRT. Is there anyone, guys, who can give this a try? Excuse me.
So I could
Oh,
try.
I've got enough people tonight, eh? Oh, okay, ma'am. You can give it a try.
So we're gonna start by saying that angle R is equal to angle R because it's a common angle.
Okay. You are saying angle R Let me just write that here. Oh, and we are saying angle R is equal to angle R, reason being a common angle. Okay.
Yes. And then
And then
so I'm trying to
oh, okay, it's fine. Let me just maybe do this. Is triangle PRS. PRS is this one, and triangle SRT. SRT is this one here.
and then angle
And then
S2
okay,
is
S2 is this one and
equal
that
to
one.
angle P because of what is this?
Times
10,
code theorem.
yes, 10 chord theorem. And
Okay, I agree. Then we are going to say angle P there is equal to, you are saying that is equal to S2. Then the reason you said is tan chord theorem. Tan chord theorem. Okay, and then
angle T would then be equal to angle S because of third angle, right?
you are saying angle S is equal to angle what? Angle T.
Because of a third angle.
Oh, okay, that is T2. Oh, I agree. That is the third angle of a triangle. Therefore, now triangle RPS is similar to triangle SRT. SRT. Does it make sense to everyone, guys? Because now we have proved that these triangles here are similar.
Yes, sir.
Are
Yes,
you
sir.
guys sure? Oh, okay. So number B is requiring us to prove that SR squared is equal to PR times RT. So anyone, guys, who can give this one a try? It's not that bad, eh? Is there anyone, guys, who can give this a try? If you are wrong, we will correct you.
Okay, so I think you first going to figure out your proportions. So I have PR over RS.
Okay, you are having PR over RS, okay? Over
Equal
RS,
to
okay? That will be equal to
SR
SR.
over RT, and that is because of similar triangles.
Wait, you said PR over SR is equal to SR over RT.
Yes.
Okay, let me write this. You are saying RT here. And then you said similar triangles. Similar triangles. Okay, and then?
Then you cross multiply. Then you get SR times SR, which is the same as SR
SR
squared,
squared or RS squared. Oh, yes.
is equal to
Uh,
PR times RT.
S squared is equal to PR. My P is better there. Times RT, then you are done. Oh, yeah, that's correct. Does it make sense to everyone? Oh, thank you for giving a try to that question. Does it make sense to everyone, guys?
Yes, sir.
Oh, okay. But I hear feedbacks from few people, and I saw almost 9 people in the room. Does it make sense to everyone, guys?
Yes, sir.
Yes, sir.
Oh,
Yes, sir.
thank you, guys. Thank you, guys. They are still in the room. Then now let me erase this. Let me erase this. Erase. But keep in mind that RS squared there is equal to PR times RT. Okay. So now let's go to number C, which is requiring us to prove that triangle PQR is similar to triangle PTS. PQR is this one. Okay. We want to prove that this triangle is similar to PTS. PTS is this one. Oh, this is good. This is a good question. Anyone, guys, who can give this question a try? Are you guys still there with me? Or you left me? Oh, okay. Wanna give it a try?
Yes, sir.
Oh, yes, ma'am. You're more than welcome to give it a try. I'd love that.
Okay. So angle P is equal to angle P because it's common.
I agree that angle P is an angle. I write that is equal to angle P. I write that as well. It's an angle. It's a common angle. Okay.
And then angle S1 is equal to angle R because exterior angle of a cyclic quad.
Okay, you are saying now angle R is equal to angle S1, right?
Yes.
And then that is exterior angle of a cyclic quad. That's my cue there. Okay.
And then angle T1 is equal to angle Q because of third angle.
You are saying angle Q is equal to angle T1 PST, okay, or PTS. That is angle T1 is the exterior angle of a cyclic quad. Okay, and then now what do we do?
That means triangle PTS is similar to PQR
Okay.
because
I
of
agree.
angle.
Because of this is similar to triangle PTS. You said because of?
Angle.
Oh, yes, I agree, 100% correct. And then, oh, yes, we are done with number C. Thank you, ma'am, for giving that question a right, 100% correct. Now let's proceed to the last question of this part, example 15. Number D is requiring us to prove that that RT over PT is equal to R squared, RS squared, all over PQ times PS. Is there anyone, guys, who is willing to give this question a try? It looks horrible, but not horrible when you attempt it. Is there anyone, guys, who is willing to give this question a try? If you are wrong, you get corrected. If you are right, oh, that's okay. Keep it up. Just feel free to give it a try. Oh, maybe you're still trying to think on how you will approach this question. Let me just give you maybe 2 minutes, and then I will appear again after 2 minutes and ask, how far are you winning? Yeah, 2 minutes. Very nice. Excuse me. Oh, guys, I gave you more than 2 minutes on the clock. How far are you? Are you winning that side?
So I'm stuck. I did attempt to do the question, but I got stuck because I don't know what to do next.
Oh, okay. How far did you go with it?
I got as far as PQ over PT equal to RS square over RT times PS.
Oh, can I just please write whatever you're saying down? You are saying, or maybe let me erase this for some space to write. We proved that. Okay. So you were saying,
I got as far as PQ over PT equal to
you are saying, where's my pen? You said PQ over PT.
Yes, that's how far I got, yeah. Equal to
Okay, PT, that is equal to,
RS square,
that is equal to RS squared.
yes, over RT times PS.
Oh, you are saying RS squared all over
RT times PS.
RT times PS
Yes.
times PS. Okay. And then now when you got here, what do you think you can cook in order for you now? But this is not food. How did you get here?
Initially I did the thing that we did in the previous question by saying PQ over PT equal to PR over QS because of similar triangles.
Oh, okay, that is very important. I thought you just dived into this part, but okay, if you started there, oh, that's 100% correct. You need to have that in order for you to come here. And then now, how do you think you are here? As a mathematics student, I think you can cook something now to prove that, to prove this. You're almost there. What do you think?
Yes.
Yeah. What do you think?
I'll need to think about it longer.
Okay, let me maybe give you 1 minute. It's now 8:44. At 8:45, I'll just remind you. You're almost there. Almost there. Oh, it's now already 8:45 on my clock. Did you get it?
No, sir.
Oh, okay. Let me just continue from this step. Here you can just multiply by RT. Then this is an equation. Whatever you do on the right hand side, you also do on the left hand side. So okay, times RT here. Now this will cancel out with that. Okay, we will be left with PQ times RT over PT is equal to RS squared all over PS. Okay, we are now here with times by 1 over PQ on both sides. 1 over PQ times by 1 over PQ. Okay, this cancel out with that. Therefore, we are left with RT over PT is equal to R S squared all over P or over PS times PQ. Then you are done just like that. Do you now see it?
Yes, sir. Thank you.
Oh, okay. Yeah, that's how. Sorry, yes?
Sorry, I have a question, sir.
Oh, yes, ma'am. You can ask.
Sir, can I ask, how did we get to like RS square if we like multiplied by RT on both sides?
Which part are you talking about?
Um,
Are you talking about this part here?
yes, and since we cancelled, we multiplied by RT and it
RT.
cancels out the RT, wouldn't we be left with like RS over PS instead of
Yes.
RS squared?
Oh, okay. Wait, let me do this. Let me do this. We had something like this here. We had something like this over. This is PQ. And then that is equal to. And then here I had just RT times. Then we didn't have that there. Okay. We were here, right?
Yes, sir.
So what was your question again? Because what I did here, I multiplied by RT
Yes.
on both sides. Yes.
Yes.
Here. Yes. Do you agree that this will cancel out with that?
Yes, sir.
Okay. Therefore, I'll be left on the left-hand side with PQ times RT all over PT
Yes.
is equal to RS squared all over PS.
Oh, so my question is, how do we get like the RS squared?
Oh, you mean this one?
No, sir. Like, yeah, since we started off with RS.
I'm now lost. I don't understand what you're talking about.
From
This
the
RS
first
squared.
one, from the first one to yes to that one.
From this part to this one.
Mm.
Oh, yes. Initially, this is RS squared, this one.
Oh,
Do you see that part?
oh, yes, sir. Yes, sir.
So after this RT cancelled out with this one, we are left with the numerator RS squared all over PS. Do you get this part?
Oh, sorry, sir. My screen was not showing the full thing. So yeah, I was not able to see the
Okay, no. It's
top.
fine. Are
Oh,
you
thank
now
you, sir.
okay with Are you now okay with everything here?
Yes, sir. No problem.
Oh, are you sure?
Yes, sir.
Okay, thank you. Then let's now move to the other part. They are saying using sides now to prove that triangles are similar. Converse of theorem 2 now. Okay. If the corresponding sides of two triangles are in the same proportions, then the triangles are similar. Okay. If you are given that triangle ABC, which is this one, this is ABC, triangle DEF, okay. And then with these ratios that AB over DE is equal to AC over DF is equal to BC over EF. You are given that. You can come to the conclusion now that angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F. Then now triangle ABC will be similar to triangle DEF. Reason being, the sides of a triangle are all in proportion. Does this converse of theorem 2 make sense to you guys?
Yes, sir.
Oh, okay. Thank you, guys. They're saying now in example, okay, they're saying we can prove that two triangles are similar by just showing all three pairs of corresponding sides are in the same proportion. All the ratios are equal. Okay. Now example 16 is saying in the sketch alongside AP is equal to 16 PB is equal to 14 centimeters, AQ is 20 centimeters, QC is 4 centimeters, and BC is 27 centimeters. Now we are required to prove that triangle APQ is similar to triangle ACB. So we don't have angles, we only have sides of those triangles. Now we can just use the ratios. If the ratios are the same, then we can conclude by saying, oh, these triangles are similar. Then we can just take AP over AC. Okay, our AP is 16 and AC will be that 20 plus 4, 24. 16 over 24 will give us 3 over 2. We go again to PQ over AC, and then PQ over, PQ over CB. I'm sorry, guys. Then that will give us 18 over 27, 2 over 3 as well. Then the last one, we go for the outer letters in the triangles, AQ all over AB. That will be 20 over 30. That is still 2 over 3 because now the ratio is equal. Every ratio of these triangles is equal. Then you can just come to the conclusion that triangle APQ is similar to triangle ACB. Does this part make sense to you guys?
Yes.
Yes,
Are
sir.
you sure? Are you sure?
Yes, sir.
Oh, okay. And then we can just, maybe at least I will just send these exercises, guys, there in the channel for you guys to do on your spare time. Then on our next session, when we meet, we'll start doing the corrections of these exercises that I will send there. Otherwise, we are almost there, guys. If maybe we will move with a good pace on the next session, we can finish with Euclidean geometry. With 2 or 1 lesson, we will be done. Otherwise, let's end here for tonight, guys. Thank you for attending. Appreciate it. I'm now logging out of the lesson. Have a good night, guys.